Okay, perfect. So hopefully now all of you can see us. We'd like to extend a welcome to all those present. We have ones from Windsor, Toronto, Ottawa, and even Winnipeg this morning. And so it's 7 a.m. in Winnipeg, so we thank you for waking up with us. My name is Jacob Hunter. I'm a third-year student in the Civil Engineering Technology program at St. Clair, Windsor. When you read the description for this event, we could have the next slide. When you read the description for this event, you would have noticed a key term, that word discussion. And we're really excited to be able to share what we have today. But we also really look forward to your own participation and different questions you have throughout. That being said, since our local circumstances don't allow us to be able to meet in person, we're all on Zoom this morning. So before we officially begin, we just want to run through a couple functions of Zoom so that the hour that we have together goes smoothly. If this is your first event on Zoom, welcome. Thanks for choosing us. We'll make sure you're nice and comfortable. If not, if this isn't your first, well, these will just be a few quick reminders for you. So we want to please ensure that you have your screen set to speaker view. As you've noted already, we as well, the shared content has been spotlighted. And so then by setting to speaker view, along with the spotlighted video, you'll see exactly what you want, what we want you to see, and the content that we're sharing with you. So at different points throughout our presentation this morning, we'll be asking you, the audience, some questions. And at these specific points in the presentation, we ask that if you would like to answer, to please use the raise hand function. And if you're unfamiliar with Zoom, it's right under the reactions button where that second screenshot is. So you hit reactions, it should come up raise hand, and then you can hit it. You can still go back one. So we'll call on you. We'll try to unmute you from our end. It'll give you a pop-up screen. Would you like to unmute? And then just before you answer your question, please just share with us your name, where you're from. If you think of something while we're speaking throughout the presentation, a question that you want to ask or something that you wanted to share, we also have a chat function. So you see that right at the bottom where that red arrow is pointing. You can send it there to everyone, but please be aware that we might not be able to touch on it until one of these question and answer periods. We want to emphasize this morning that this is a discussion panel. It's a conversation. What we're going to talk about today is something that we believe will become a more prevalent issue either right now or in the coming years. And we look forward to seeing how you view it. The other thing that we want to do is we want to explain the limits of our knowledge, right? You're smarter than us. You might hear something that isn't quite right. You might see something that isn't described in as much detail as you would hope, and that's okay. We're just happy to share with you what we're able to. That being said, a few students involved in the presentation today work with a consulting firm. One's even worked with a municipality in the past. And so combining that experience with what we've learned from the college in the Civil Engineering Technology course, this presentation will partly take view from the view of a technologist. Why might it be a good idea to view something from this perspective? Well, a technologist's role, whether working for municipalities, working for consulting firms, or wherever, is to help apply the real-world knowledge onto drafting and design plans, what the professional engineer will eventually see. They're the ones in the field and have that direct communication with engineers. As a student, if we can go back a slide, Carlos. As a student, one of my favorite things is to teach somebody with an engineering degree how to use a program like AutoCAD or Civil 3D, programs that are designed to assist all in design work. The knowledge that we're going to be presenting today is going to be based primarily off of two regions in southwestern Ontario. We can have, yes, thank you. Windsor-Essex and Chatham-Kent. You can see them at the very south of Canada. However, as we're aware, as most of you are aware, this issue extends much more province-wide than just where we are. So that being said, before we get too much further, we want to give you an overview of what we're going to talk about today. We're going to look at our agenda. So first, we're going to talk about the importance of shoreline. Afterwards, we're going to see some data and engineering analysis, look at an actual report. After that, we're going to interview with a real-life shoreline professional. Afterwards, we'll talk about the civil design process, and of course, we'll talk about different permit applications and how one might go about getting those. So when you clicked on this event, the screen should be very familiar with you. When you clicked on this event on the NEM website, it was described as a dynamic panel discussion about civil engineering with students and professionals discussing the unique world of shoreline protection. And so we tricked you a little bit because we're the students, you're the professionals. This morning, we're not talking about career paths. We're not talking about what it's like to be an engineering student, but rather we're talking about something that we care about and we believe will be a more prevalent issue in the years to come. So that being said, we want to start off our presentation by introducing our first question and answer. So we want to hear from you. Why do you think shoreline protection is important? We'll give you a few moments to gather your thoughts. So what do you think? So it must be important if you join an 8 a.m. discussion about it. So if you see in the chat, Dale answers for us partly. It's water levels in the 5 Great Lakes have never been higher, and you're absolutely right. Thank you for sharing that, Dale. So thank you, Dale, for your participation. We'll move on a little bit now. We will be asking a few, from Chris Patterson to everyone, water is reaching properties not seen before. Another excellent point. Thank you. So then let's talk about it a little further. Let's discuss it. Oh, maybe I'm going a little too quick. Thank you, Gail, for your comment. Increased development along shorelines pose risks to the natural environment. Thank you very much. So we appreciate everyone's participation. We will move on at this point. So why is shoreline important? Well, I have 3 points, and there's many more points. There's erosion, rising water levels, and of course, we want to protect properties. So you guys added lots more, which are absolutely right. So to understand why shoreline is important, we do have to get on the same page about it. Shoreline protection engineering is a branch off of civil engineering. Shoreline protection in Ontario involves the protection of properties along the Great Lakes or other natural bodies or streams of water. Its aim or purpose is to decrease and try to eliminate erosion. As previously mentioned, lake levels have risen, and as a result, many people with properties on them are concerned and in need of a solution. Take a look at these next two pictures. Now, these two pictures were actually taken on the same day after a late fall storm came in and hit the area hard. It's kind of rhetorical, but can you tell which home was protected? The home with the shoreline protection. We can have the next slide. So shoreline protection then, as it relates to engineering, allows a consultant to design and engineer creative natural stone shorelines or even metal sheet pile wall designs that are exciting, visually appealing, and most importantly, solve the problem. Ontario is full of beautiful shorelines, and we want owners to be able to protect them. I love this picture on the right here in Norfolk. I took that myself on a bad iPhone camera, just highlighting the beauty that Ontario has in our shorelines. So then when I talk about shoreline protection as an issue, I just don't want you to take my word for it. Look at this graphic from IRCA, that is the Essex Region Conservation Authority. So in this graphic, we're helped to appreciate how local lake levels have increased, whether due to snowfall in the past couple of winters, or as this picture illustrates, winds, specifically from the northeast. Why would we care about the wind? Well, you see, strong winds is what pushes these lake waters against the shoreline. And it's the force, the destructive nature of the waves and the wind is what's significantly destructive. So when researching for this presentation too, we looked at the Essex Region Conservation Authority's website. And I loved this picture, this little graphic that came up. This was the first alert. It tells us that please note that due to high water levels, they're experiencing an extremely high volume of calls and permit applications, right? They're getting swamped, overwhelmed. Really emphasizes the importance, what we're up against. But what more is involved in knowing what's happening to our shorelines? Carlos Cruz will now help us to see some data and engineering analysis that goes into the design process. Thank you. Carlos, please.
Hello, everyone. So my name is Carlos. I work for a civil engineering consultant firm in Windsor-Essex region. Right now we're moving to London area too, so we're getting big. Also, I'm part of the directors of OACETT in Windsor-Essex, which actually it's helping this event to happen. So really happy to be here and glad to be sharing the content about shoreline protection and the engineering side of that. So one of the questions, the second question that we're coming right now is why does a shoreline have to be engineered? So I would like to hear from you guys. Take a couple of minutes to hear what you guys think. Why does a shoreline have to be engineered? Anyone? Can someone read the questions for me? I'm sharing the screen. Jacob, can you please read?
Yep. So Chris Patterson says to ensure downstream effects are mitigated.
Good point. That's a great point.
Gail Willis shared with us to protect from erosion, unstable slopes.
100%. Yeah. Well, that's a good point. I think the idea behind a shoreline being engineered is that we need to prove scientifically and mathematically that doing a shoreline, we can prove that shoreline's gonna last, right? And with reports and documents and with drawings and understanding um, the engineering side of it, the data, and that's why we're gonna move on with that. So, the first point that I pointed here in the engineering side is analyzing the soil, right? In every construction, you got to take a look in the soil. What type of soil do you have, right? If you're building a house, what type of soil do you have? Because it's important in every construction, the geotechnical aspect of it. And shoreline is not different, right? Because you're building in the beach, so it's a place that no one likes to build it on, basically, right? It's usually the soil is a little bit different and more sand too. So places that you need to study. And so I brought it in this chart, and this was a report that was analyzed in Leamington area, the place that we work on. And that shows basically the grain size distribution. So the sieve analysis and all the studies that are analyzed through the engineering aspect of it. So the first topic I would say would be the soil and the sedimentation, the foundation based on our shoreline and how we're going to build that shoreline in terms of the soil that we have. The next point is the lake level analysis, right? We as engineers, we collect data, and of course, from conservation authorities, we're able to get data from and understand the 100-year storm events and the 2 years. And for people that don't know about it, it's basically the statistical aspect of, hey, in the last 100 years, what was the case, the statistical one case scenario in the water level for that case. So in this case, I just bring it on the water level information here, and with the years, the 2 years, 5 years. We in our consultant, we actually do jobs similar, for example, to development of subdivisions and site plans and infrastructure work. Similarly to that, when we design a sewer, for example, we have overland flow roads, and we have the design of the sewer, the pipe capacity, and the hydrographs and the studies of the environmental aspect of it. In shoreline, is the same way. The lake level would represent the environmental aspect and the hydrology study of it, which we can get this information from data, and we can get from doing some calculations in Excels and all that. The next point is wave conditions too, because waves are important, right? The waves are always hitting the shoreline. And I guess Chris, in the next topics, he's going to probably be able to talk a little bit more about that. But basically, the wave is the lateral forces that are going to the shoreline and the structural aspect of our shoreline, and understanding and doing some calculations and analyzing the heights and analyzing the peaks period. So I just represented a little bit here, just showed a little bit of one chart that shows the slope, the heights of the waves, and things that we study with that. Also, the material of the shoreline. For example, you can use stone. What type of shoreline are you using, right? What is the best for that region? And how can we understand the structural aspect of the shoreline? And there are a couple manuals that we can take a look at. For example, Coastal Engineering Manual for the United States, and also looking into the conservation authorities websites to understand a little bit more what type of material you want to use, the armor sizes for the structures, and so on and so forth. And the next thing that we need to take a look at it is the erosion, which is very important. The erosion aspect in terms of the geotechnical aspect as well, in terms how this is going to slope, how we going to have the slope going to the shoreline. That all affects how are you going to build that shoreline, and how the slope is going to influence that, and the mitigation, and how you're going to work with that. We can see an image that I just showed here, and that shows in the report the different options for the city of Leamington, Kingsville, and Colchester, basically all this Point Pelee area. And the engineers came up with different options for each portion of that development here. So we can see option A and option B and option C. So different types of shorelines was proposed for the Leamington area. And I would like to talk a little bit about just one portion, the option D, which is the offshore breakwaters for the southwest shore of Point Pelee, basically. And in the Point Pelee area, because it's a very narrow area, and in Point Pelee, actually, for people that don't know about Point Pelee, basically is the southernmost point of the mainland of Canada, and is encountered in Leamington area, and is a conservation area. And we can see that in Point Pelee, we have structures that was a breakwater. They created that breakwater outside of the Point Pelee, engineering and thinking about that to make it a little bit far, because of the sand and all the beach area is not a lot, so they created that. And and we can see the prices and how much they cost for each data of the engineering aspect here, as the option B, the option C, the option D. And we can see that could be very expensive, right? And actually, I want to give that to Chris to explain a little bit more about that. I guess Chris has more knowledge that I do, and he's probably going to be able to talk a little bit more about the costs effects, and how that the benefits of a shoreline in terms of the benefits comparing to the cost, which we can see in the next slide as well, in terms of the cost and the total benefits, and the total cost for each option that's showing in this report, and actually the total benefit of it too. So I would like to give back to Jacob right now, and I guess Jacob would like to introduce Chris. You're muted, Jacob.
Get myself unmuted. Thank you. So now we'd like to take a minute to interview a real life shoreline engineer. And we're really happy to welcome Chris Patterson with us from the Windsor area. And so Chris, we had a few questions for you today.
Sure.
Carlos, did you want him to talk first about what you were just describing?
Yeah, sure. I would like to see if you want to talk about what I just described it, or if you want to just go on and just talk about shoreline.
Sure. So these costs, I'm assuming this is from a shoreline study. And what happens is, in the shoreline study, the engineer that's doing the study will have to give a cost estimate of each area in which they want to protect. They don't necessarily give a specific protection design, but they give kind of an option for a price. But the problem with the price is that it's very tough for, let's say, homeowners to pay for these altogether. You know, you'll never get 20 to 25 or 30 to 35 homeowners all together to pay for this shoreline protection. That's why it's so difficult. So when we get individual homeowners that come to us and need shoreline protection, we can go to these studies and we can look at these costs, but per homeowner, it's a lot different because the contractor has to go out and do one property instead of doing, 30 at a time, in which there would be cost benefit to that, right? In terms of scale. So these costs are important, but at the end of the day, who's going to pay for this, right? These studies are all great, but I think they really need to be narrowed down to individual homeowners or residences, because they pose a problem for, in terms of scale, right? So it's a little tough, but it's good that they include those. It's hard to cost estimate those things. So I give it to those engineers.
Awesome, thank you. So yeah, so now Chris, we'll just we'll move more into a personal interview with you. And so we just had a few questions for you. So the first one that we had for you is, if we could just maybe have that screen up.
Okay.
Yes, thank you. So the first one we had for you is, what's your current role at your job?
So currently I'm a shoreline engineer at Baird AE. And I think the three main things that I do, the first one is client contact. So a lot of homeowners don't have a great idea of what shoreline protection is or what they can achieve, right? Sometimes conservation authorities are not available for contact or consult or meetings, right? So client contact is the first thing. And homeowners will call and say, well, what can I do? How much do you cost? How much does the contractor cost? And 9 out of 10 times, none of these homeowners have ever done shoreline work on the scale. So really, it's the first thing to do is to inform the homeowner and make sure that they understand what they're putting their money into, and why they're putting it and why they need an engineer, and the things that we can bring as consultants to the homeowners. So that's really the main thing: client contact, or figuring out who the project manager of the job is, who owns the cottages. A lot of these cottages on Lake Erie have multiple owners, making sure everyone's organized. So it's really important. And then the next thing is design. So once you have your client contact and what area they're in, and what conservation authority you're working with, you then go and start to do the design. So you figure out from the homeowner what they would like to see on their shoreline, and you work with them on a final solution, right? So you go back and forth saying, well, this area of your property, we could do this or this. And it really depends on what the existing conditions are, right? So you have to do a site visit, which is included in the design, and you have to figure out what's there right now, and then what can be put there to protect it. If there's nothing there, then you're starting brand new. But if there's existing protection already, sometimes it poses a problem, because you have to either remove that or you have to incorporate that in your design. So it's very important to look at the existing conditions and then come to terms with the homeowner on what the proposed conditions are. And then the last thing is contact with the conservation authority. So contacting the homeowners is important, but making sure that you can get that permit is almost even more important, because that's what you bring as a consultant. You should be bringing the value to them to get them their permit so that they can do the shoreline protection, right? And it's not just conservation authority, it's Department of Fisheries, it's Ministry of Natural Resources, and then the newest one, the Ministry of Environment and Conservation. And each one of them have different requirements, and they trigger on different things. Department of Fisheries, you need a permit when you're in the water. Ministry of Natural Resources, you need a permit when you're doing a new wall, but you don't need a full permit when you're doing a repair wall. So there's some different things that you need to understand as a consultant so that you can help the homeowner, right? So all of those things kind of come together to get the permit and to finally get that thing installed. I guess another part of it is working with the contractor, right? As engineers, you don't always have contractors included in the job, but if you do, you have to make sure that they are working to your design specifications. And if they have questions, they have to ask you, because if they just go and install whatever they want to install, then you won't get a conformance letter at the end, and the Conservation Authority won't be happy, or any of the other agencies won't be happy with the work that's done. So contractor contact is a side part, but it's also a very important part as well.
Excellent, thank you. And yeah, the permit application process is something we're going to touch on later in this presentation too. Before we move on to the next question, we actually had a question from the audience, if you're okay being put on the spot there, Chris.
Sure.
Abishola, pardon me if I'm pronouncing that incorrectly, A mechanical engineering student, they were wondering, is shoreline protection only for highly priced property areas generally? It's the first part of their question.
So it's not just for highly priced areas. I mean, it does work better in highly priced areas because the realistic part of it is the shoreline protection kind of has to match the value of the property. If you have a more valuable property, you want to protect that property more, right? When we're on Lake Erie in the Amherstburg, Leamington areas, some of these cottages are, low priced, dilapidated, vacant. So protecting those areas is a lot harder because if the owner doesn't have money to update their own cottage, then how are they going to pay for the shoreline protection, right? But there are processes in which you can design economically, right? And it's, economic design is not just steel, not just wood. It's very important in shoreline too. So that's why it's so important to work with the client first and figure out what they want to do, what their budget is. And then you really work to budget design something that is just going to protect their property. If it's unprotected, you want to just get maybe some rocks in there, right? Maybe some blocks. And it gets as crazy as finding things that they have on their property, right? If they have some rocks that are, strewn across their property, we'll say, well, you can, redesign your shoreline and put those existing rocks in a specific situation or specific location so that you still have protection, right? It's not just, well, I don't have the money, I can't do anything. There are low protection options, there are medium protection options, and there are high protection options, right? So it's not just for the high priced locations, but generally, it is, to be completely honest, those are the ones that protect their property more because the investment of their home is higher, right?
Thanks, Chris. The second part of their question was asking, is shoreline protection strictly a private interest, or does it incur infrastructure costs from the government as well? And then in what situations would that happen?
That's a great question. So it is mainly a private interest, and most of the projects I've done are only private interests. They're just homeowners that need to protect their property. But Town of Essex recently has given out a loan for protection. So it's not that the government is, paying for this. You have to pay back that loan, but they are starting to help homeowners protect their shoreline because these investments are large. I mean, shoreline protection is very expensive. The contractors are very expensive. So are the engineers, right? So the government and agencies, it seems like they are now starting to, look around and give some money out, because if they don't, a lot of these areas will remain unprotected or damaged, and you'll start to have coastal processes that you really don't want. So I'm happy that's happening, but most of the time the government, I mean, in terms of cost, is not included in these projects. It's mainly private interest and mainly just private homeowners that are paying for it.
Perfect. Well, thanks, Chris. Hopefully we answered or give you some insight. Oh, perfect. Thank you. So Chris, we'll turn it back over to you. We'll ask you a more personal question. We've talked about it a lot today, but why do you personally think that shoreline protection is important?
Right. So I really think it's important for conservation. I mean, that's what the agencies, the conservation authorities are for, right? But if shoreline protection isn't prioritized, then we are going to lose property, and we are going to lose areas that are unprotected. And it's not just homeowners, it's national parks, it's Point Pelee, it's around the Detroit River. You really want to conserve and protect those areas so that they remain as natural as possible, right? If we don't do anything, then you'll have areas along the shoreline that are really eaten out and really damaged, where the properties on either side are protected. So you'll have almost a hole in your shoreline, right? And the water levels are getting to the point where they are doing that. Any areas that are unprotected are going to get damaged by the water, right? So I think it's really important for conservation, and I think it's really important to keep the coastal processes as natural as they are, and that's really where the engineer comes into play, right? Homeowners, a lot of them have their own ideas, right? Well, can I put this deck down here, or can I put can I put pieces of my foundation that I just dug up? Can I put it at the water? And the answer is normally no. And there are things that homeowners don't understand, right? Like if you were to put concrete from your foundation, if it has rebar in it, that rebar is going to leach into the water and damage the water, right? So there are many, many different things that need to be looked at. And it's not just as easy as throwing some things on the shoreline, even though it's done so often, right? So it's important to organize all of these things and make sure we're conserving the right areas and, making sure we're keeping things as natural as possible.
Absolutely. Thank you very much. The last question that we had for you, thank you for touching on the importance there. Is just a quick one. What can a property owner do if they think that they need shoreline protection?
Right. So what I always suggest is going to the conservation authority, your local conservation authority, and having a consultation or a meeting with them and explaining, well, what exactly is happening at the property and what the homeowner is looking to do. Now, that these days, it is very hard to get a hold of the conservation authorities. So if the conservation authority is not available, you can go to your local municipality and say, okay, I'm looking to do this. What do I need to do? Most of the time they'll say you need a permit from the conservation authority to get, a building permit or whatever, but at least, you get your name into the municipality and the conservation authority so that everyone knows that you are looking for permits, right? Otherwise you'll just be doing shoreline without any permits, which is not suggested. Now, if that doesn't work, you can contact a shoreline engineer and ask, what are my next steps, right? If the conservation authority isn't available, then we really have to take things in our own hands and start the design without them, because unfortunately most of these properties, we just can't wait. They're emergency areas that need to be protected as soon as possible. And if we wait 8 months for the conservation authority to come back to us, then we run the risk of the design changing, right? If you leave it for 8 months, the design done in January might be different than the design you have to do in October, November. So time is extremely important in these cases. So first, it's the conservation authority. Second, it's the municipality. And third, contact a local engineer to find out what your options are, or just to start the design.
Perfect. Well, thank you very much, Chris, for joining us today. We really appreciate your insights, and we hope that what you've been able to describe to us could potentially help somebody here.
Hopefully. Yep. Thanks for having me on.
Thank you, Chris.
Take care, guys.
Take care.
So to this point in our presentation, we've talked about the importance of shoreline. We've looked at some data and engineering analysis, and we've even talked to a shoreline engineer. But what happens with the actual civil design process? Blake Toms will now be discussing that.
Thanks, Jacob. Hello, everyone. My name is Blake Toms. I'm in the civil engineering program at St. Clair College, and I'm going to discuss from a technologist standpoint the civil design process. So the first step of the process is a topographic survey, and topographic surveys collect coordinate points as well as elevation. And these points are used to get a lay of the land, provide existing conditions that are then designed from. So in order to perform these topographic surveys, there's 3 common survey equipment that are used. Each of them can be used individually or together depending on the conditions of the site. The first piece of equipment I'm going to talk about is a GPS unit shown at the top. This unit is typically attached to a rod that the surveyor uses on site. It's controlled by a tablet that collects the coordinates and elevation points taken to detail out the shoreline and the existing conditions. The GPS communicates with satellites to give it information, and the more satellites it's able to connect with, the more accurate the data. When conditions might not favor using a GPS, such as tree coverage, a total station might be used. This instrument is shown on the bottom left here, and it's usually placed on top of a tripod on site. The surveyor would attach a prism on top of a rod, and that would communicate with the total station in order to collect the data. Just like the GPS, it's controlled by a tablet that collects these points. The only downside of using a total station is that the points don't have geographic coordinates. It's just points where you can use multiple equipment together is the GPS and total station. They're able to work together by attaching the prism and GPS both to a rod. This provides very accurate points, very accurate elevations, and the geographic coordinates. The last piece of equipment I'm going to discuss is the leveling rod shown on the right. This is the manual method of surveying, less used today when gathering data. It takes two people to perform this survey, one person to look through the scope of the level and another person to hold the measurement rod. This is where benchmarks are used. These are known elevation points that are referenced, and the surveyor would walk along the shoreline and detail it out with the measurement rod, giving new elevations reference to the benchmark. Next slide, please. So after all this data is collected, the next step of the process is to begin the design. So all the points taken from the topographic survey are then uploaded into the CAD software Civil 3D. At this point, the technologist can create an existing surface that can be designed from. Now, this is where the extent of the technologist works ends. They then hand off what they have created in the software to an engineer, then carry out the rest of the design process. So we have another question. Our next question to the audience would be, what is another role a consultant has in the shoreline process? So just to reiterate, we have touched on the data and engineering analysis and a few of the points that Chris brought up earlier. Does anyone have some ideas of what another role a consultant might play?
So we just have a quick clarification from Gail Willis that she wanted to share. So I'll just mention quickly, sorry, Blake, what she mentioned in the chat. She just wanted to clarify conservation authorities are available to discuss applications. It's highly recommended that conservation authorities are engaged before shoreline design is finalized. The conservation authorities need to respond to applicants within certain timelines. It does not take 7 to 8 months for a permit. So thank you for sharing that, Gail. We appreciate that.
And I do see we did get a question here, or an answer to the question. So coordination with the conservation authority, that's the point. Consultants definitely play that role. Does anyone else have an answer to the question? Okay. Well, if not, I'm going to turn it over to Jocelyn Gagne, who's going to go into further detail about the permit application role of the consultants.
Hi, everyone. So my name is Jocelyn Gagne. I'm a third-year student at St. Clair College, as everyone else knows well. And I'm going to touch on the permit application process when it comes to shoreline protection projects. So the first question that homeowners often ask themselves is, do I need a permit? This isn't only when it relates to shorelines, but also just any renovations they might be doing. If they're doing a fence, for example, they might think, do I need a permit? And oftentimes they might think, no, it'll be fine. But when it does come to shorelines, permits are definitely needed in order to do any type of protection process, especially when we are working with the waterways and the Conservation Authority. Any type of project that's looking to stabilize and protect any existing shoreline, even if it's just small, as we see in these pictures here, like a simple riprap stone application, it's very minimal, but this still would need a permit as well. anything that falls under docks, boat lifts, shoreline stabilization, and any repairs to existing shorelines all will require permit applications, and they all will need to be approved before you can do any construction, no matter what your design is. Okay, so on a shoreline protection project, it is usually highly recommended to use a consulting firm. And you may ask why. If you can get the design done, you could carry out the rest of the process yourself. And you could, however, consulting firms often are preferable because they organize the project and they follow through with the shoreline project from start to finish. They'll facilitate everything from the site assessment, the engineering and design, to the permit application process, and as well as a bit of the project management, coordinating material supply, and just working to arrive at the best solution possible and make sure that everything's in place to do so. On this timeline, we can see these 4 major steps. We're not going to touch on project management, but we are aware that the consulting firm can also have some coordination to do with that. However, we're just going to stick on focusing on the permit application process right now. So when looking to obtain a permit, it can become a bit of a complicated process, and that usually is why a consulting firm is preferable. Depending on where you're located, that would determine which conservation authority you will have to speak with, as Chris did touch on in the interview. However, in specific circumstances, sometimes any of these other agencies listed, especially in our region, Lower Thames Conservation, this Fisheries and Oceans of Canada, Parks Canada, IRCA, the Ministry of Natural Resources and Forestry, any of these agencies could also need to be consulted depending on your specific circumstance and the shoreline you're trying to protect. Permits will need to be obtained specifically from the Conservation Authority, but these other agencies could also require permits depending on the circumstance as stated. So looking at the permit application process itself, the problem is kind of how to go about knowing which permits you need and which permits won't apply to your situation. And the consultant is usually very good at knowing this, and they will work with these agencies. There's usually a 3-step process, and I'm going to use IRCA for an example, as that is the conservation authority in our area where we are focusing. So this could vary depending on the conservation authority, but it will remain relatively similar. So when going to IRCA, there will be a 3-step process for the permit application. And the first part of the process, as Chris did talk about on his interview as well, is the pre-consultation. So if you don't know where to start, the homeowner could go to the Conservation Authority and have a pre-consultation, and they will touch on the permits they would need and where they should head for the next step. If they should consult a consultant firm, if this is a project that will need permits, if this is something totally different, they will be able to point you in that right direction and set you on the right path to start the project. And once you start that process, whether the consulting firm is the one that does this or you contact them after the pre-consultation, once we go through the design, the analysis, and we're arrived at the solution which you would like to put in place, that's where the application will be completed. So the consultant would complete the application and submit the drawings and everything that you are looking to do on your shoreline. And that will be submitted to the Conservation Authority, and there would be a time period in which you will have to wait to hear back from them. As Gail did touch on as well in the chat, it is not going to take 7 to 8 months to receive approval or denial for your application. There usually is a time period, and it does not exceed that time period. And then the review process, the staff of the organization which you submitted the permit to is going to review what you're looking to do and review everything to do with the shoreline project. And at that point, they will either issue your permit to you or deny, and they will give you suggestions as to why. And in that case, you could edit your design, look back at what you're looking to do and make those changes, and then resubmit in that case. So the benefit of having a consulting firm is they can take care of this entire process for you. And when the Conservation Authority lets you know that, hey, you may need to contact one of these other agencies, they will know the process is in place and be able to do that for you as well.
Thank you, Jocelyn, for talking a little bit more about the permits application process and everything that goes into it. We're just so thankful for this presentation. I'm just so thankful for my team and Jacob that worked really hard on that and putting all the team together. To conclude, I would like to conclude touch basing a little bit about, in summary, what we talked in this presentation. We showed a little bit about the shoreline and how that's very important for us here in the Great Lakes area right now, and how the lakes are changing, and how this statistical plans and all this engineering perspectives are occurring. I'm so thankful for Chris to come up and speak to us too in an engineering perspective. And as Jacob said, we are students, so we're just learning, just doing our best to get this presentation together. So I'm just so thankful for everybody here. I would like to know if we have any more questions. Maybe if Jacob can help me out on that too. I'm sharing my screen here, so I don't know.
Yep, of course. So Dale just had a point that he wanted to add, just something else to consider. He says, consider also wave erosion from transverse waves generated by commercial shipping vessels, if applicable to specific properties.
100%. That's a very good point.
We also have somebody raising their hand. Christy, would you like to share your thought or your question?
Hi, I'm Christy from University of Ottawa. I'm a recently graduated master student. I'm also majored in civil engineering. My research is about a very related background. I'm doing the numerical simulation and experimental studies on the buoyant jet, which is kind of effluent discharged into the river or water body, and like kind of a shoreline. So I want to ask Chris, if you have any related studies or numerical simulations in the consultant process. So in my study, I used the open form, but I know there are some commercial software to simulate the jet or something like the effluent near to the river. Did you use those software?
Great question, Christy. So I've never used the simulations or the software myself, but when I am doing my master's as well, not in shoreline engineering, but I did look into doing shoreline engineering simulations first. And I think it was called Wave 3D or Waveform 3D, one of those. I contacted many companies to find out, what could be done, because what I wanted to do is simulate different types of protection and simulate the waves on those protections and find out, in a more finite element analysis, how will these different protections perform in different waves. You have to look at overtopping and basically where the water will go, right? So I think Wave 3D was one of them, but also I know at the University of Windsor, they were working on a simulation for standalone floating, and don't quote me on this one, but I think it's standalone floating the wind turbines. They were trying to float those on the water, and they were trying to look at how the waves were going to impact and change the way the wave turbines work. So I may be able to forward you that if you're interested. And then, yeah, I could probably forward you some of the other programs. I just can't think of them off the top of my head.
Thank you so much. It's kind of the very first time I know somebody is really doing something related to my study, because in Ottawa, most of the area not living in the like the big lake area. Yes, we know that the flooding is kind of a threat to most of the people living in those coastal or near river areas. But I think in this industry, it still need to develop in future in other area. And thank you for your answer. It's really good.
No problem. If you want to put your contact info in the chat, I can we can email back and forth.
Okay, I will put my email here. Thank you.
And I know how it feels. Sometimes shoreline engineering can be like you're out on an island. No pun intended, but there aren't many engineers. So we need more in this area, because it's very hard to do it all without some good qualified engineers.
So thanks, Chris. Thanks, Christy. We do have to wrap up in just in a few minutes. We might be a little over time, so I apologize, Sarah.
No problem. You still have time.
Oh, perfect. Carlos, could we go to our last slide? So then, just on behalf of NEM, St. Clair College, and OACETT, we want to thank everyone for being able to attend our presentation this morning. This page is just some of the sponsors. Sarah, you might have noticed I added another logo, just Baird, for their help for us personally today. We used a lot of insight from them. So we hope that we have given you some insight into the unique world of shoreline protection. If you're interested in some of the sources that we use, just email me after and I'll help to be able to provide them for you. It sounds like then we still have a few minutes. So if people are interested, we can unmute, and then we can feel free to interact with one another. There's also that super appealing red leave meeting button if you're looking to avoid some conversation. But again, thank you to everyone.